Thank you very much for the opportunity to present my article, the findings of my article, Optimal Rules for Advertising Budget Allocation Across Movie Versions Marketed in Sequential Distribution Stages. It's a pleasure for me to present the findings there. It is about movies, and movies are marketed in sequential stages. Like the first stage is the first week showing movies in theaters. Second stage is showing movies in the remaining weeks, and then third stage maybe selling movies via DVDs. And that was originally published by Lim and Lee in an article in Journal of Advertising Research. And I'm extending their work because there were some issues missing. Now, I will present the whole stuff a little bit simplified in a way that by movies, we have the complication that movies are shown on screens, and the screens depend on the expected audience. But I will only discuss how the budget will be determined given this audience in order to have a more simplified understanding of the whole thing. What we do in marketing is that if we want to allocate budgets or determine budgets, we have to define sales as a function of the input. That means the budget. And this function, the sales response function, is the orange line here, has diminishing marginal returns because there must be some interval where the costs are higher than the returns for the sales. And therefore we have, if we subtract the budget from the sales here, we have an optimum there. So that's the basic understanding. Now, how can we get from this understanding to formulas? Here's again the same graph. So we have a sales response function, which is typically in marketing a function where we have the budget, and that is raised to the elasticity. And here's some kind of constant. So the elasticity is defined as a percentage change of sales divided by the percentage change of the budget. So it's a relative measure. And typically, if you increase the budget by 10%, what you can expect, as we know from many empirical studies, is something that the sales only changes by 1 or 2%. And then 1% divided by 10% is 0.1, and that's the elasticity. So, and then profit is the sales response function times the margin, of course, what you earn from your sales minus the budget that you invest. And then you can derive the optimal budget formula as elasticity times margin times optimal sales. And that this optimal sales was missing in this Lim Lee article. They wanted to determine the optimal budget across stages only with respect to the elasticity, but it is also needed the optimal sales, the size of this of the stage. Now the problem is a little bit more complicated, because if we consider stages, then not only the elasticity in the respective stage is counting, but also we will have carryover effects from the budget spent in the first stage. It carries over to the second stage, and then finally to the third stage. This makes it a little bit more complicated. And in order to understand this structure, I have here a slide with a distribution stage 1, distribution stage 2, and 3. The budget in the respective stages will influence the sales, but also the carryover to the next stage. Yeah, and therefore, we have what I call a cascading model structure. Here with 3 stages as assumed in the Lim-Lee article, and I assumed the same, but another contribution of my article is that it can be extended to any number of stages for the budget allocation. And in comparison to the Lim-Lee article, they can only determine the percentages of a total budget that you spend for the stages, but you have to determine the total budget by yourself. While in my article, I can determine the optimal budgets for every stage, not only the percentages. Now, if we have this cascading structure, I can show this optimal solution. Here's a sales response function for the first one, only for the first stage. For the second stage, the carryover from the first stage is coming in addition in this response function. And here for the third stage, we will have the carryover from the first to the second and from second to the third. And then I can show that the optimal budget is given proportional to elasticity and the size of the stage, but also by the carryovers that also result in some carryover sales. So this is the structure. And here are some formulas that show the cascading structure, because for the advertising budget depends on 3 stages, the second budget on 2 stages, and the third only on 1 stage. And in the article, I will also give exactly the numbers for the different elasticities, including the carryovers, which I will not explain in detail here. But I will then come to the question how to optimize. And as you will see in the article, but also I will show a slide with an Excel sheet that I can come up with a very simple solution, because instead of the optimal sales in the optimality equation, I assume the expected sales, and that makes it then very simple to calculate. This is a heuristic, and you can solve it very easily within an Excel sheet. And of course, the question for a heuristic is it very close to the optimal numerical solution that can be determined with optimization software? And the answer will be yes, it will be very close. And then the main question is, of course, how do you get the data? As I pointed out, you need elasticities and carryovers from one stage to the other. And the question is, if you are a manager and you want to do this calculation for the budget, have you been already on the job for several years? Then you have data from the past, and you may be able to estimate the elasticities and carryovers with econometric methods or software from the data of the past. If you do not have this kind of software, maybe also not the expertise to apply this software, then you might directly take a look into publications, like in the Journal of Advertising Research. I mentioned the Lim-Lee article in 2018. There you will find the numbers for these estimates that are coming from movies over several years that have been shown in the theaters in the US. If you do not find publications for your own problem, you may also go to meta-analyses of advertising. A meta-analysis is an analysis of many individual studies. So they collect all individual studies of advertising, or on advertising of entertainment products, or on advertising of movies as a special case. And then you get the mean value over all individual studies, and you may take this value for the elasticities. And there's also a meta-analysis for carryover effects that you can take as values for your estimation. And then finally, you may apply an Excel sheet. Here you will find the Lim Lee article, and they had empirically estimate, sorry, what's that? Oops. Oh, sorry. Oh, sorry for my mistake. So you will find here the percentages across the stages. For my own article, the assumed values, and you may have different data that are given here. Then if you assume, for this example, 1,000 as sales, as total sales, then you get here the numbers for the sales. You can also compute the carryover of the sales. You have here the input of the elasticities, here the input of the carryover effects. This constant A in one of the formulas can be also calculated very easily. And from all these elasticities and carryovers, you will get summary elasticities, 11, 12, and so on. And based on that, you can easily determine the optimal budget. And I also have run numerical optimization in order to show that the profit for both solutions is very close to each other. So although the budgets are a little bit different, as a percentage is here, the profit is very close. And therefore, it's a very simple solution that is understandable by managers, and it is extendable to any number of stages, and incorporates the difficulty of carryovers across stages. Yeah, thank you very much for listening.
Thank you so much.